Hi, boys and girls, and welcome to Unit 11. We are still springing into geometry and measurement because it is the season of spring. Now, this unit is different from the others that we've completed because it's all about geometry. I can hear the excitement in so many voices of my visual learners because this is where you will probably shine the most. So our goal is to compare and contrast varieties of polygons, especially triangles and quadrilaterals. Now, this is not our scale for the whole unit, but it is our scale for this lesson. Now, you need to already be able to identify and classify polygons. If you can't, don't worry. We're going to look at a few in the learn portion of our lesson. And then we need to be able to differentiate. Notice the word different. We need to be able to tell the difference between shapes based on their number of sides. So that's where we're going today. Now, the practices that we need to use are reasoning abstractly and quantitatively. We will have to examine and critique the reasoning of others. We will need to model. We're going to show our thinking a little bit with pictures. And then we need to look for connections between the shapes and telling them apart. So what is a polygon? A polygon is a closed shape. Here is a closed shape, but it is not a polygon. It is a closed shape. This is a shape that is a polygon. Let me close it there. So a polygon is any closed shape that is created, that's not one either, that is created by line segments. So my circle is not a polygon because a polygon is created using line segments. And a polygon must have 3 or more line segments that meet at vertices. That is why an open shape like this one that does have line segments, but unfortunately it's open, that is why this shape is not a polygon. And then polygons are broken up into 2 groups. We have regular polygons and irregular polygons. A regular polygon has sides that are all congruent, which means they're all the same length. Is this a regular polygon? No, because I can see that these 2 sides look like they're the same length, but they definitely are not the same length as this side. So this shape would be considered an irregular polygon. See the difference? Okay, now let's take a look over here at the chart. We have the number of sides, angles, and vertices. Sides, angles, vertices. And remember, vertices are the points at which the line segments meet. A triangle has 3 sides, 1, 2, 3, and 3 vertices. A quadrilateral has 4 sides and 4 vertices. And boys and girls, keep in mind that these numbers are based on the number of sides, not necessarily what the shape looks like. Both of these shapes that I've drawn are both quadrilaterals, but they look different. So keep that in mind. In order to tell what type of polygon you have, you must count the sides. Let's look at triangles. Are triangles polygons? Yes, they are, because they have 3 vertices and they have 1, 2, 3 sides that are created from line segments. A line segment is a straight line that has a definitive beginning and end, and it's not curvy like this. So this is not a line segment, but this one is. It has a beginning point and an ending point. So here we have triangles. Triangles are considered triangles. Let's go back, because they have 3 sides. And feel free at any time to pause the video and take notes, because you are going to need this information when it's time for you to start answering questions. And it'd be great to refer back to it when you need to. So we have three different kinds of triangles when we're comparing them based on their sides. So an equilateral triangle has sides that are all congruent, or they're all equal. And notice that I use the symbol of one line to show you that each one of these sides are equal. An isosceles triangle has at least two sides that are equal. So these two are equal, and this one is not. And a scalene triangle, oh boy, in a scalene triangle, all of the sides are completely different. When I say different, I mean the length of their measurement is different. For example, this side could be 5 centimeters, this side might be 4 centimeters, and this side might be, I don't know, maybe 2 or 3 centimeters. Each side is different. For this one, each side could be 5, and then the bottom might be 4. And then for this one, an equilateral, notice the term equal, all the sides are, let's just say, 3 centimeters. We can also compare triangles by their angles. And notice the symbols I use to indicate that. We have a right triangle. Why is it a right triangle? Because it has one right angle. And the lines are perpendicular. Perpendicular lines can look like this, or they can create a perfect corner. And we indicate perfect corners by boxes, okay? An acute triangle has 3 angles that are less than 90 degrees. Now, when we say 90 degrees, a 90-degree angle is a right angle. And do you see how there's all this space inside? That means that this triangle is less than 90 degrees. So a triangle where all of the sides are less than 90 degrees is called an acute triangle. And then we have the obtuse angle, or obtuse triangle. An obtuse triangle has an angle that is greater than, look at that angle, greater than 90 degrees. If we were to put a perfect corner here, you can see that this side of the triangle goes way outside of that line. So this is considered an obtuse triangle. These two sides are acute. These two angles are acute. But because we have an obtuse angle, which is one that is greater than 90 degrees, it's called an obtuse triangle. Most of you can look at this or figure this out just by looking at it. Now let's look at quadrilaterals. I've created this chart for you, and you might want to write it down because it's really helpful. A quadrilateral is any shape that has 4 sides, but then they split off into parallelograms and trapezoids. A trapezoid only has one pair of parallel sides. There they are, okay? A parallelogram has opposite sides that are parallel. There they are. And the opposite sides are congruent, which means they are the same length as well, okay? But under parallelograms, we have rectangles and rhombi, or some people say rhombuses. Now, what makes a rectangle a rectangle? Rectangles have 4 right angles, which means every single side is a corner, and then these sides are perpendicular. And we know they're perpendicular because they create right angles. Only perpendicular sides can create right angles. And then we have squares, which are both rectangles and rhombuses. A square meets all of the rules for all of these. Okay, it is both a rhombus and a rectangle. Got it? Okay. You might want to pause the video and look carefully at these shapes so that you can see the difference. Notice in the rhombus, the sides are not right angles like they are over here. See that? And all of the sides are equal. That's what makes a rhombus not a rectangle, because a rectangle must have 4 right angles. Let's practice. How would you describe each of these shapes? Okay, 1, 2, 3, 4, 5 sides. And then, okay, I'm going to erase this and make it a little more clear to you. This is a regular polygon and a pentagon. It's a pentagon because it has 5 sides. It is a regular polygon because all 5 sides are congruent. All of the sides are the exact same length. Got it? Now, this one, we can see these 2 sides are not only parallel, but they are the same length. And these 2 sides are the same length and parallel. So we know, and this is a right angle because look at those perfect corners. Okay? So this is a irregular polygon, and it is a rectangle. It is also a parallelogram, and it is also a quadrilateral because it has 4 sides. So we just worked our way back up the chart that we learned about on the other page. You see the path here? What we just drew, or what we saw, was a rectangle, a parallelogram, and a quadrilateral. Miss Crab drew a shape that has 3 sides, 2 of which are congruent. Oh man, I know exactly what this is. If these 2 sides are congruent, this is not. This is a polygon because all the sides are the same, and it is also a isosceles to go back, and I described it that way. Okay? Now we're going to do one together. Pause the video and see if you can get these right. And we'll talk about your answers when we return. Okay, I have here an obtuse isosceles triangle because I believe these 2 sides are the same length, but this one is longer than the other 2 because that's how you can create an obtuse angle when the base is really long. So we know that this is an obtuse isosceles triangle. We know that it's an irregular polygon because not all of the sides are the same. The square, oh my gosh, look at this list. It is a regular polygon because it is a closed shape and all of the sides are the same length. It is a quadrilateral because it has 1, 2, 3, 4 sides and 1, 2, 3, 4 vertices. It is a parallelogram because it has opposite sides that are parallel. It is a rhombus because all of the sides are the same length. It is a square. It is a rectangle because opposite sides are parallel and we have right angles. And then it is a square. Obviously, we recognize that shape because all of the sides are the same. This list describes this square. And down here, Stephen has a quadrilateral that has only 2 parallel sides. The quadrilateral that only has 2 parallel sides is the trapezoid. And we can label the sides. These 2 are the same length, and these 2 are not the same length, but they are parallel. Last to the you do. Pause the video and try this on your own. I'll be back with the answer. Okay, boys and girls, take a moment and check your answers. See if you got your answers correct. Write down any questions that you have, and then take a look at the scale for what you did today. If your answers were wrong and you can explain why they were wrong, you are a 2. But if your practice problems were right and you can explain why, you are a 3. Pause the video and we'll see you next time.